A 2.5 kilogram mass is moving at 4.5 meters per second west towards a 1.5 kilogram mass moving at 3 meters per second east. Calculate the final velocity of the 2.5 kilogram mass if the 1.5 kilogram mass rebounds at 5 meters per second west. What? Okay, let's have a look at how we would do this. There is a lot going on here. We need to break it up. What's the first thing we're going to do? Boren, what did you tell me to do before? Draw a diagram. All right. So let's start. So I'm going to put a line down the middle here, and we will have before collision and after collision. Okay, let's keep it nice and neat, nice and separate. So before the collision, we have a 2.5 kilogram mass moving west at 4.5 meters per second. We also have a 1.5 kilogram mass in that direction, traveling at 3 meters per second. So that's our initial condition. Our final condition is we have, so our 1.5 kilogram mass, after the collision, our 1.5 has bounced backwards. Okay, they've had a collision and it's bounced back the way it came because it rebounded at 5 meters per second west. So now we need to work out what has happened to our 2.5 kilogram mass. We don't even know the direction it's heading. Is it going the same way as 1.5? Has it bounced back completely? We don't know yet. So we need to look at the momentum that has happened here. So let's look over in our before side. Let's work out the total initial momentum. So our momentum is going to be, so which side should we call negative? Do you have a preference? West. West negative? All right. So that means our, so I'm going to call this block A. No, hang on, I'll call that B and A. BA. Okay, so B, the momentum of B is 3 multiplied by 1.5. I'll put momentum of B, 3 times 1.5, which is 4.5 kilogram meters per second. The momentum of A is 2.5 multiplied by negative 4.5. Okay, I should put this in here. So that way is negative, that way is positive. Okay, so the momentum of A, 2.5 times negative 4.5, negative 11.25. So if we add those together, we get our total momentum before the collision is negative 6.75, which means that is 6.75 kilogram meters per second in the negative direction, west. Okay, so we have our initial momentum, negative 6.75 or 6.75 kilogram meters per second west. So that means our momentum after the collision must also be exactly the same. So our total momentum over here is going to be that. 6.75, or we'll call it negative. Negative 6.75 is our total momentum. So our total momentum is made up of the momentum of A plus the momentum of B. We have our total momentum. We're going to work out the momentum of B, then we'll be able to work out the momentum of A. All right, so momentum of B is 1.5 times 5 in the negative direction, so negative 7.5. Okay, so we've got B, 1.5 kilograms, 5 meters per second west. So therefore, the total momentum of B is negative 7.5 in that direction. Write that a bit neater. Okay, so we've got the momentum of B, we've got the total momentum. So if we rearrange this equation here, the momentum of A is going to be equal to the total momentum minus the momentum of B. So we've got negative 6.75 minus negative 7.5, which is 0.75. So that 0.75 is the momentum of A. Okay, momentum of A is 0.75. I'm going to go back up the top here. I'm running out of time. Running out of room, I should say. Momentum of A is equal to 0.75. And so because momentum is equal to mass times velocity, 0.75 is equal to the mass of A multiplied by the velocity. So velocity is, what's that, 0.75 divided by 2.5, which is 0.3. So our final velocity of A, okay, which is what we wanted to work out, the final velocity of the 2.5 kilogram mass is 0.3 meters per second. In which direction?
East.
East. How do you know?
Because it's positive.
Because it's positive. If this came out to be a negative, it would mean that it's going west again because of our sign convention over here. But because it is positive, we know that it is 0.3 meters per second east. Now, this looks like a lot of writing on the board. It looks like a lot of maths. But if you break it down, work out the total initial velocity. That'll give you the total final velocity as well. And then if you've got the total final velocity, you know that everything in that final section must add up to that total final velocity. You should be able to work out what's left. Boren.